So this is my chapter 9 problem. What is the Lewis structure, molecular geometry, electron domain geometry, and the polarity for a phosphite anion with a -3 charge? So first we got to draw the Lewis structure. This is done by grabbing your periodic table and you look at the groups of each element, and that's going to determine the amount of electrons. So P is phosphorus, which has 5 at the top, so it's going to have 5 electrons. Then O has 6, and since there's 3 oxygens in phosphite, so it's going to be 3 times 6 for oxygen, which is 18. 1 times 5 for phosphorus, which is 5, and then because there's a -3 charge, you're going to add 3 more electrons. So there's a total of 26 electrons. Once you figure out the number of electrons, you construct the Lewis structure. P is going to be in the center, and then you're going to have 3 O's with lone pairs around it, and from here you would count your electrons: 1 2 3 4 5 6 6 6 2 up here, and then you add these right here, and that's going to give you a total of 26 electrons. Now for the electron domain geometry, this phosphite, and I almost forgot, you're going to put this Lewis structure in parentheses because of the -3 charge. This is the official way to write that. Lets everybody know there's a -3 charge around it. So the electron domain geometry is a tetrahedral. It's tetrahedral because there's a central atom, and it has these substituents at each angle, which basically gives it a triangular pyramid shape. And for the molecular geometry, it's trigonal pyramidal because the 3 oxygen atoms are repelled by the electron lone pair. So it looks like a trigonal pyramid. And it's polar because all trigonal pyramidals are polar. So that answers those questions, and that's how you find the Lewis structure, molecular geometry, electron domain geometry, and the polarity of the phosphite anion with a -3 charge.